Hello dear students, I am CG Joy, Mathematics teacher, Pallotti School, Thrissur. Today I am going to discuss about the introduction part of chapter 10 circles. That is the concept of secant, tangent, the number of tangents from a point to a circle and the length of the tangent.
Lesson 10 Circles. What is a circle? We all are familiar with the term circle. It is nothing but it's a collection of all points in a plane which are at a constant distance from a fixed point. And the terms related to circle, that is radius, chord, diameter, sector, segment, we all are familiar with all these terms. In this lesson, we are first going to discuss when we have a line and a circle are given in a plane. Understood? That is a line and a circle. Okay, there can have three different situations when we have a line and a circle. Understood? That is, look into these three different figures. In the first figure, we have a line PQ and a circle. Okay, and there is no common point between the line PQ and the circle. That means this PQ is called the non-intersecting line with respect to this circle. Is it clear? Non-intersecting line. This line PQ is called non-intersecting line with respect to the given circle. In the second figure, this line PQ intersects this circle at two distinct points. Okay, intersects means both the line and the circle has a common point. Let it be A and B. Okay, that is here the line PQ intersects the circle at two distinct points. So, this line is called the secant of a circle. Secant. So, what is a secant? It's a line which intersects the circle exactly at two distinct points. Okay, here in this figure, those 2 points are A and B. Okay, that means A is a point on the circle as well as a point on the line PQ. The same way the point B. Now we are moving to the third situation. Here you can see this line PQ intersects the circle exactly at one point, or a line PQ and a circle have only one common point. Okay, let this point can be denoted by A. So, in that case, the line PQ is called tangent to the circle. Tangent to the circle is the line which intersects the circle exactly at one point. Okay, so these are the three situations when we have a line and a circle on a plane. Understood? In the third figure, the line PQ intersects the circle exactly at one point. Okay, that is A. Okay, that means that point A is common between the line PQ and the circle. Okay, and this point where that line touches the circle is called the point of contact. Point of contact. Okay, so these three situations are clear, children? Yes. Now we are moving to, we are going to discuss about the second and the third situations, that is the tangent. Can we explain like this, children? Let us listen. See, the tangent to a circle is a special case of tangent, secant. Okay, that is the tangent to a circle is a special case of secant of a circle. Why it is so called? Okay, this secant is definitely, that means AB, the line segment AB is a chord. Okay, and that means it has two endpoints. When these endpoints, okay, reduce to one single point, okay, as we move, see like this, understood? To the left side, it will, both these two endpoints reduce to one single point. This is the case happens in the third case. Okay, that is why the tangent to a circle is a special case of secant, where the two endpoints of the chord AB reduce to a single point, that is point A. Understood? That means here the tangent is a special case of secant. Understood? Okay. Now the another point is, okay, see how many tangents we can draw for a circle. Tangent, okay, don't confuse with the tangent and the secant. Okay, what I asked, how many tangents can be drawn? Since in the beginning I told a circle is a collection of infinitely many points in a plane which are at a constant distance from a fixed point. Infinitely many tangents we can draw at each point. Okay, from this point, okay, you can draw a tangent. This point you can draw. You can select a point on the circle, and with respect to that point, you can draw a line which is common to the line PQ and the circle. So a circle can have infinitely many tangents. Understood? The same way a circle can have infinitely many secants also. Okay, and another point is with respect to this tangent, okay, this point of contact A, you can draw exactly two parallel to this PQ, you can draw one more line with a point of contact. Okay, you can draw a pair of tangents. Understood? Okay, that means two tangents which is parallel to each other. That should be noted very carefully. Okay, but you can draw infinitely many single tangents. Understood? Because a circle is made up of infinitely many points in a plane. Understood? These are very important concepts with regard to the circle. Then only we can easily explain the remaining topics of this lesson. Understood? The next point is, suppose we have a line or line segment. Okay, see, we have a line segment AB and a point C. What is the distance between the given point C to the line segment AB? Okay, in order to find out the distance, anyhow we have to connect both of them through a line segment. Okay, that means you can join this point C to any point on the line segment AB. But what is the actual distance between the point C and the line segment AB? Okay, it is nothing but the shortest distance. Okay, if you join this AC, okay, these are the different ways that this point C can be joined with, okay, but these are not the exact distance between the point C and AB, and that is the shortest distance from the point C to AB. And that shortest distance is the perpendicular to AB. That means the shortest distance is always perpendicular to AB. Okay, so that is the actual distance between a given point and the line segment AB. Our next point is number of tangents from a point to a circle. Okay, see, suppose you have a circle. Okay, see, you can mark a point in three different positions. Okay, in the first case, you can mark a point in the interior, a point which can lie in the inside of the circle. And in the second case, you can mark a point on the circle. Okay, and in the third case you can also mark a point, okay, in the exterior or which is lying outside the circle. Here inside the circle, on the circle and outside the circle. And what we are going to discuss now? The number of tangents from a point on a circle. Okay, so through this point, okay, we have to, what is a tangent? Number of tangent, right? That means it's a line which intersects the circle exactly at one point. So I am going to draw a line. This is a ray. If you it is definitely touching at this point, but if we extend, what happens? This line is intersecting the circle in two distinct points. So it will become a secant. What we need, the number of tangents from a point to a circle. So if a point which is lying inside the circle, no tangents can be drawn. Clear? In the second case, what I told, you can mark a point on the circle, and we have seen that, okay, when we have a point on the circle, you can definitely draw a line, okay, which is passing through the point on the circle, and we have seen that that point is what we call the point of contact. Okay, so this is the second case. If we are marking a point on the circle, you can draw exactly one tangent to that circle. Likewise, if you can mark, since it is the collection of infinitely many points, infinitely many tangents can be drawn. You can mark the point here B, okay, with this B another tangent, okay, here at this point, okay, here if it is C, you can draw another tangent which is passing through the point C. Likewise, you can locate infinitely many points on this circle. Through these points, you can draw exactly one tangent. Understood? And in the third case, if you are marking a point outside the circle, okay, outside the circle means here I already marked the point, that is point P, okay, exterior, point P is exterior point. Okay, how many tangents can be drawn? Okay, so I am marking from this point, definitely you can join a tangent which is passing through, okay, this point B. Likewise, you can get another tangent which is passing through this point A and the external point P. No other tangents can be drawn. Why? Because if you are marking a point C like here, isn't it, children? So if you join this point C, it will definitely cut the tangent at 2 points. Understood? So you cannot. Understood? So if you mark a point, okay, here the external point, if the point P is lying outside the circle, you can draw exactly 2 tangents. Okay, so these are the 3 cases, that is when a point which is lying interior to the circle, inside the circle, no tangents. On the circle, exactly 1 tangent. If the point lying outside the circle, you can get 2 tangents. Okay, so we will have very important results or theorem based on this that we will discuss later. Understood? So these are the very important points should be known before we start the exercise and the theorem sections. Okay, the next point to be discussed is the length of tangent. Okay, so in the last case we have seen that when we have a point which is lying outside the circle, you can draw exactly 2 tangents to the circle. That means A is the point of contact common between the circle and the tangent, okay, and B is the point of contact between P, that is the point P and the circle. Okay, so it is very clear this is not the line segment. So what is the length of the tangent? From which point to from which point? Okay, so the length of the tangent is nothing but it is the length of the line segment from the point of contact and the external point. Is it clear? Okay, the length of the line segment from the point of contact to the external point. Isn't it? So from the figure, what is that? PA, line segment PA and PB. This is the length of the line segment, okay, from the external point P and the point of contact. Okay, so this is very important. Okay, as we move to the next problems, okay, this should be very clearly known. Okay, that is the length of the tangent is the length of the line segment from the external point P to the point of contact. Isn't it? Okay. Yes, these are the very important points to be discussed before we start the theorems and the exercise work. I hope you all have got very clear idea about the points which we discussed today. Thanks for watching my video and supporting me. Thank you all.